Alright, we're going to go ahead and continue working on this projectile motion worksheet. So I've been told that you should have worked through the first 4 or 5 problems. So just to err on the side of caution, we'll go ahead and start on problem 5. So some fireworks are fired vertically into the air from the ground at an initial speed of 80 feet per second. The equation for the object's height h at time t seconds after launch is given by this quadratic right here. Find the domain of the function. Now, the domain of the function, generally speaking, for a quadratic would be all real numbers. That being said, negative time doesn't make any sense. So time is our input variable. You can kind of think of it as like the x if we were to graph it. And height is kind of like your y variable or dependent variable. So of course time can't be negative. That wouldn't make physically speaking. And this firework is going to be fired up in the air at 80 feet per second, and eventually it's going to hit the ground. And at that point, the height can't be negative either. So essentially, if I were to do a quick little sketch of this equation, note that it's a parabola opening down. That's going to look something kind of like that if I were to sketch it. So that domain is essentially going to be from the time it launches until the time it hits the ground. So the time it launches is at 0 seconds. So that's free information. The time when it hits the ground, we don't know. So we'll have to compute that. We do know that it will hit the ground when the height is 0. So we're going to go ahead and set the height to 0. And solve the equation. Now, there's multiple ways to solve this quadratic. You're welcome to use the quadratic formula. It does factor. We can look for a common term, and you will note that 80 is divisible by 16. So 80 divided by 16 is 5. So that tells me I can factor out a negative 16 and a t. That will leave me with t minus 5. And the reason I know that to be true, I can go ahead and distribute to verify. Negative 16t times t would be negative 16t squared. Negative 16t times negative 5 would be plus 80t, so the factoring is correct. So according to the zero product property, this would be a true statement if the first factor equals 0 or the second factor equals 0. So those are essentially my two solutions, t equals 0 and t equals 5. Of course, I could divide both sides by negative 16 here, and that would be 0, and just add 5 to both sides here. So my domain is 0 to 5. Essentially, what that means is our firework will be in flight from 0 to 5 seconds. Let's go and take a look at this next example. The Apollo's Chariot, a roller coaster at Busch Gardens, moves at 101 feet per second. The height of the ride at time t seconds can be represented by that equation. What is the maximum height reached by this ride? So note that it's another quadratic function, and we want to find the maximum height. And note that the leading coefficient is negative, so it's another parabola opening down kind of like this. So that maximum height will be at the vertex. So our vertex is going to be at negative b over 2a. So negative b over 2a is going to be at negative 101 over 2 times negative 16. And let's go ahead and compute that. So I'll get my calculator here. So I'm going to take negative 101 divided by the quantity, 2 times negative 16. And let's see if we can switch that to a fraction. So that'll be at 101 over 32. Now notice, this tells me the x-coordinate of the vertex. And the way our model is set up, our x variable models time, the y variable models height. So remember, the vertex is a point in a two-dimensional space. It has two coordinates. We only know one coordinate, which in this case is 101 over 32. So if I want to find the other coordinate, I'm going to take this and plug it into the equation to get the corresponding output. So if I look at my equation, I got negative 16 times the input squared. So I'm going to plug in my input, 101 over 32 squared, plus 101 times our input, 101 over 32, plus 10. And there's our y value. I'll go ahead and write the exact value as 10,841 over 64. That's the exact value. And then let's go ahead and answer the question now. So the question asks for the maximum height. Well, it's going to be at the vertex. The x-coordinate represents time. That tells us when it will reach its maximum height. The y variable represents height. That is the maximum height. So the maximum height is around 169.39. And that's going to be in feet. So it tells us this roller coaster has a maximum height of just over 169 feet. So take a look at the next example. Eva is jumping on a trampoline. Her height, h, at time t can be modeled by the equation h at t equals negative 16 t squared plus 20t plus 6. Would Eva reach a height of 14 feet? So let's go ahead and figure out the maximum height. So that maximum height is going to be at the vertex again. So this is just like the previous equation, or previous problem. We're going to figure out the vertex, which is at negative b over 2a, which is at negative 20 over 2 times negative 16. And let's go ahead and punch that into the calculator. Negative 20 divided by the quantity 2 times negative 16. And that's 0.625. Now keep in mind, 0.625, that's not her height, that's the x value, which represents time. So to get the corresponding y value, you have to plug it in to the equation. So I'm going to take 0.625, plug it into the equation. So you can see there I just plugged it in for t there, and that's 12.25. And this is in feet. So the highest height will be 12.25 feet. So no, she will not reach that height. The highest she's going to go is a little over 12 feet. She won't make it to 14 feet. Let's look at the next question. A diver is standing on a platform 25 feet above the pool. He jumps from the platform at an initial velocity of 10 feet per second. Use the formula h at t equals negative 16t squared plus vt plus s, where height is h is height above the water at time t seconds, v is starting upward velocity, and s is his starting point to write an equation to model the dive. So essentially, we're going to go ahead and construct the equation. So v at t, or v times t. So v is, as it says right here, starting upward velocity. So it says right here, initial velocity is 10 feet per second. So that's 10. And then notice it specifies s is his starting point, which is 25 feet above the pool. So there's the equation. So part A. Let's see if I can write that small. Ooh, it's going to be tight. Okay, there it is. So there's our equation. And then find the diver's height after 2 seconds. So what we're going to do there is plug in 2 into our equation. So So negative 16 times 2 squared plus 10 times 2 plus 25. And that would be, let's see here, we have an error. What did I mistype in? Negative 16 times 2 squared plus 10 times 2 plus 25. So what that tells us, with negative 19, is already going to be underwater, right? So at that point in time, he's going to be underwater. 2 seconds of flight. We got negative 19, so that tells us he's not above the water anymore. All right, so let's go ahead and take a look at the next question. All right, so let's look at our astronaut here. So an astronaut on the moon throws a baseball upward with an initial velocity of 10 meters per second, letting go of the baseball 2 meters above the ground. The equation of the baseball pathway can be modeled by that equation. The same experiment is done on Earth, which the pathway is modeled by that equation. How much longer would the ball stay in the air on the moon compared to Earth? So it's basically asking for the flight time. And note that your gravity constant is different between the two. So let's go ahead and take a look at this. So let's start off with the moon. So starting off with our moon equation, which is h at t equals negative 0.8 t squared plus 10t plus 2. So if we look at this equation, it's going to be in flight until the height hits 0. And we need to solve that equation. So if we set the height to 0, we just need to solve the following quadratic. And to solve that, we'll run the quadratic formula. So if we run our quadratic formula, it's going to be negative b plus or minus the square root of b squared. Notice b squared is 100 minus 4 times a times c all over 2 times a. And we're going to go ahead and figure that out. So let's go ahead and type that in. So I got negative 10 plus square root of 100 minus 4 times a times c. And it's all going to be divided by the quantity 2a. Notice we get a negative answer here, which doesn't make sense for the ball to be in flight for negative 0.19 seconds. Remember, your quadratics will have two solutions, and you need to pick the solution that makes the most sense in the context of the situation. So we tried the plus on the quadratic formula. Now let's try and switch it to a minus. And instead of retyping the whole thing in, you can just change that plus to a minus, divided by 2a. And there we are. There's a solution that makes more sense. Now at around about 12 to 12.70 seconds. Now let's go ahead and do the same thing for Earth. And we're going to use the Earth equation, which is the second one. And we're going to set it to 0. And it solves the same exact way. You'll run the quadratic formula. So that'll be negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And let's see what we get there. Now remember, the plus or minus is going to give me two solutions. If you recall from last time, addition didn't give me a feasible answer, so I'm actually going to set it up with the subtraction. And divided by the quantity 2 times negative 4.9. And we get 2.22. And if you think about physics, this makes way more sense. There's way more gravity on Earth, so the ball's going to be in flight for far less time, whereas on the moon it's going to float for a lot longer. Now the question is, how much longer would the ball stay in flight in the air on the moon compared to on Earth? You just take the difference of the two. So we have 12.70 minus 2.22, which is roughly 10.48 seconds. All right, so that concludes this lecture. So that should finish up the projectile motion. I also sent an in-class activity that's going to be worth a quiz grade. The better you perform on it, the more points you will receive. So everybody on the in-class activity that's about to be presented will get 100%. It's just the more correct or the answers I receive, or the higher the performance, the more credit you will receive. So we'll go ahead and transition to that in-class activity, and I'll hopefully see you in the near future.